Good morning, everybody. Welcome to DataON fourth quarter webinar. Very excited to be here today with a great keynote audience and also presenter that will be sharing their technology with us. The topic today is what's new in Azure Stack HCI, accelerating performance with Intel Optane technology, and why StorageReview.com gave an Editor Choice Award. We have a really good lineup of presenters that will share their experience with you, and feel free to use the chat room to ask questions as we go forward. So our presenter today, we'll start off with myself doing a quick introduction. My name is Howard Lowe from DataON. I will introduce Adi from Microsoft, who will share with you what's new in Azure Stack HCI since 2019 and launch in Ignite this year. He will be followed by the esteemed James Meyer from Intel, who talks about the Optane and Intel technology, how it accelerates the storage world. James will pass that to Brian Beeler, who is the editor for StorageReview. Brian will share his finding and his research looking at the Azure Stack solution based on Microsoft and Intel technology. Then I'll wrap it up. The goal is to share these solutions with you guys and really give you guys a comprehensive view of what the industry looks like. So as we go through, at the end, we'll have some time for Q&As, so feel free to post your questions. I'll try my best to get to all the Q&As and answer all the questions. And all the information will be posted after the webinar, so you can review it later. Some housekeeping items, you will be muted throughout the webinar, and these are social media hashtag if you'd like to follow them, Adi, James, Brian, and myself. So feel free to follow us if you like. So without further ado, I'll get started. A very exciting year in 2019 in the IT industry. A lot of changes, a lot of new technology. DataON have continued to work with our partners to drive the conversion of technology into new feature and capabilities. But there's a couple trends I like to highlight, and I believe are key drivers in the world that we live in. I think number one is the emergence of hybrid cloud, ability to have a solution that delivers the on-premise capability that you have today, replacing your SAN and replacing your on-premise aging infrastructure. At the same time, ability to have a capability to integrate with the cloud infrastructure, such as Azure, so you can leverage a cloud capability in your environment. So the emergence of hybrid cloud is one trend we continue to see evolve in the marketplace, and our customer base continue to take advantage of. The second is, as we continue to do that evolution, the come to presence of hyper-converged infrastructure. Consolidation, new technology allows hyper-convergence to happen, and DataON continue to work with our partners from Microsoft, Intel to deliver that technology to our customer base, so you continue to leverage these consolidation to reduce costs and increase performance. As technology evolve, I think Moore's Law computing continue to be the key driver, ability to have new processing compute capability, virtualization, ability to have faster SSD and drives. These are drivers that allows us to architect a solution that meets the demands of today's workload. And these continued driver are what keeps the hardware piece of it to maintain the application aspect of our work industry today. Lastly is management. I think having ability and build a hybrid cloud infrastructure and able to manage it properly is very, very critical. Microsoft has really came out with a great management platform called Windows Admin Center that really bridges the on-premise solution to the hybrid cloud solution. And DataON, with our continued support of that evolution, has also our tool to provide that capability. So these are the key trends that we see in the marketplace that we believe will continue to drive adoption across the world, across the industry. We continue in 2019, take our customer through the journey of hybrid cloud. And what that means is we continue to help them evolve by refreshing their infrastructure from Windows Server 2012, Windows Server 16, SANs, NAS, other hyper-converged infrastructure to the new capability. And we continue to work with new customers across the industry to make that happen. And you could see that the evolution continue to exist from traditional SAN to Windows 16 to Windows 19 to Azure Stack HCI. But more importantly, many of the customers we have today not only deploy on-premise Azure Stack HCI solution, they also take advantage of Azure services. And these are capabilities we continue to want to make sure our customers understand that they have a best of two worlds as they look to refresh the infrastructure. We're very excited that as DataON make the Microsoft choice, the industry, the analysts, and press briefing are also recognizing the capability of Microsoft. You will hear later from Brian their analysis from a technical point of fact why they believe and they gave the StorageReview Editor Choice Award to Microsoft Azure Stack HCI in their finding and why this solution is a great solution for the marketplace for our customer base. But more importantly, Gartner also recognized Microsoft as a visionary. They came out about 2 years ago, and they continue to grow in the market in terms of capability feature, which Adi will talk about, to make sure you understand why industry and Gartner and other industry analysts are recognizing Microsoft as a leader in this particular hyper-converged infrastructure. Lastly, the channel CRN recognized Microsoft as a leader. Without further ado, I will pass the baton to Adi, and Adi will tell you what's new for Azure Stack HCI. Go ahead, Adi.
Awesome. Thanks for the lovely intro, Howard. So today I want to focus on some of the new features in Azure Stack HCI. So if you've been following along with our journey, you might have seen that in 2019 we added a lot of capabilities for both the 2-node remote branch office small scale scenario to make it more resilient, to make sure that you maximize the utility out of the hardware that you have, and all the way up to the 16-node or even larger if you wanted to deploy cluster sets or have a lot of storage, like we support up to 16 petabytes now. And so today, some of the new things that we've built in the last year since releasing 2019 are all around hybrid features. And so I want to show a few cool demos around those and show you some of the unique hybrid capabilities that we've built. So as you can see, I included this slide because whenever we talk about Microsoft Azure, one of the biggest focus areas for us is the hybrid cloud, because a lot of our customers are still on premises, and there's certain scenarios like remote office, branch office scenarios that need to stay on premises. And so across the Azure Stack portfolio, we have different solutions for your audience. So we have Azure Stack Edge, which is a cloud-managed appliance that you can deploy. We have Azure Stack HCI, where you're running Windows Server on hardware, which lets you scale out horizontally or vertically, depending on whether you need more nodes or you need to add more drives for storage. That's our hyper-converged solution. And then we have Azure Stack Hub, which is a cloud-native integrated system and is Azure consistent, where you pay per month based on your usage. And so when we talk about this high availability and resiliency, the way this HCI stack works is we use Hyper-V for our virtualization of compute, and then we use Storage Spaces Direct to virtualize our storage there. And you get that level of concepts like three-way mirroring, like mirror accelerated parity. We do that in the software layers so that your VM can get live migrated and you're highly available. There's automatic failovers, and your storage is also highly resilient. And this is just some slides showing that. And in the last year or so, we actually doubled the number of solutions that we had, from 75 solutions to over 150 pre-qualified solutions from over 20 partners. And so this allows you to go out there and just buy the right configuration that meets your needs. And the unique thing about this is it scales as your business grows. So let's say you're deploying, for your remote branch office scenario, you have a retail store, the badging for employees is happening there. And, someone on your dev team in your core corporate office decides that it might be interesting to do some sort of computer vision to see, how many people are walking in and out of your store, or, use some sort of fancier AI to track sentiment when people are in your store. all of these sort of advanced AI features are being developed in the cloud. But with Azure IoT Edge, you can now deploy these in containers on premises. And so you can innovate with the cloud using these different libraries and functionality available to you, and then deploy them through cloud-managed modules through an Azure IoT VM on premises. So even if you lay this infrastructure now, it can scale as the technology advances and as you build future applications in the future. And so today I want to focus on some of these capabilities, on some of these hybrid hooks. So in this new release, we made sure to have Windows Admin Center is the new UI to manage your on-premises environment in a disconnected scenario. And so we added capabilities with Azure Site Recovery, Azure Backup, Azure File Sync, Azure Update Management, Azure Monitor, and Azure Security Center, where specifically for the hyper-converged story, we built out full end-to-end scenarios for the Azure Site Recovery and Azure Monitor scenarios. So this is like a glimpse of what the UI looks like at Windows Admin Center, and I'll show you demos of this going forward. So one of the biggest pieces of customer feedback that we received was DataON helped us with this. We're working with a customer, the Canadian Museum of Human Rights, and basically we saw when we were working with them that their IT staff, what they would do is every day when they got into the office, the first thing that they would do is they would check Windows Admin Center to see if there were any alerts or any errors with their system. And periodically throughout the day, after they got coffee, after they got lunch, in the afternoon, before they went home, and then even when they got home, they would constantly open up this single pane of glass to check for errors. And we wanted to make this story better so that you weren't constantly having to open up that same pane of glass and drill down and seeing if there's errors. We wanted to proactively monitor and send you alerts for useful things. And so we added capability to do exactly that. And the way the model works is we actually take an agent and we install it through Windows Admin Center on every single server. And we have published documentation, which you can see at the bottom. If you would like to do this manually, there's steps there. But the Windows Admin Center UI makes it a really 2-3 click experience for you. And so once we connect this agent to you, it basically makes it seamless to collect this data. And so this is a demo showing you how to do that. So you can see, you can go and navigate to the cluster view. And after you do that, also, I want to make sure, is this video actually playing for everyone?
I don't think the video will play very well, Audie.
Okay, we can skip over the video. I can basically just talk through it then. Here, we can go back to this. So basically what's happening in the background is Windows Admin Center is opening up a, when you navigate on the left-hand side of the menu, there's a new tool called Azure Monitor. And when you click there and you set configure, you'll see a status. If you have 2 nodes in your cluster, you would see those 2 nodes, or in this case, we have 3 nodes. And it would basically ask you to either create a new workspace or give it in Azure for a log analytics workspace, or you can select the existing one. And you can select the region. And so we'll show you drop-down menus to choose that, or a dialog button so that you can type in and then create a new one. It would show you where we're installing this agent, and when you press go, when you press setup, it actually just installs this agent. And in the background, all of that happens. And in a few minutes, you'll see a green check mark showing you that everything is good, the status of your 3 nodes, and then you'll see some default alerts that we want to opt you into. And so the way those work is for single servers or for clusters, we monitor the performance on all of them. So we monitor CPU latency, CPU usage, memory latencies, disk utilization, your heartbeats, and we basically see if there's inconsistencies or high utilization on any of these above thresholds that are configurable for you. By default, they're set to like 85%, 90%. Then we'll proactively send you an email or text. And so in this case, if let's say you have a drive failure, that data gets bubbled up to Azure Monitor every 5 minutes, and now Azure knows that there's an issue. And so this next video that I was going to show, if the video doesn't render well, you can at least see on this page that healthy status. You can see, we have 2 nodes in this setup. You can click this link at the top to see that in Azure, and at the bottom, right now, in the demo, I would have to play it for you to see those pre-qualified alerts that we've opted you into. But because this is a cluster view, we also look at the system logs for clustering. We look at health service logs. So if there's any faults with the health service, you see that as well. And so let's skip over this. And if we go back to this scenario, what would happen now is, now that we know something is wrong, Azure Monitor would immediately fire an alert. And it would send you either a text notification that you can open up and quickly see, what cluster, what node, what issue, what's the health fault, what query are you running, and all of that data at your fingertips. And that's like a summary of the information. Or you can see this sort of email with the drill down query that we actually ran. So you can see at the bottom here the exact search query, and if you had scrolled down through this email, you would see all of the data that was parsing, and you see all of that at your fingertips. So even if you're remote, you can easily try to diagnose or root cause what the issue is with your system. And so that's really big, because that allows you to, not always be checking that one pane of glass. You can access that information. And we partnered with DataON to actually build more extensions for this. So all of this data, once it's connected to Azure, it sits in a log analytics workspace in the cloud. And so for OEMs that have specific knowledge about their hardware and call home services, they've built, like DataON has built an extension to this where they can use that data, they can provide even further insights based on knowing the end-to-end stack, and then they offer a call home service for you so that in the event that something goes wrong, they can ship you a drive that you can just easily pop in and replace. And so that provides tremendous value for you, because in that situation where something goes wrong, you immediately have a fix, you're alerted, and the solution is already RCA'd and on its way. So now switching gears a little bit, the second big hybrid integration we built for the HCI scenario was integrating Azure Site Recovery, so you can protect your virtual machines. And what this means is you have these workloads that are running locally on your system. But in the worst case of a natural disaster or something happening that'll take down your local on-premise cluster or set of clusters, you need to be able to quickly migrate those VMs to the cloud. And so in the case that something happens, you want that data from those VMs to be continuously replicated to the cloud, so that in that instance, you can fail it over to the cloud and seamlessly run that same workload there. And so that's exactly what ASR allows you to do. And this demo may not work, but you can see in the virtual machines page in Windows Admin Center a pane that shows you, that you can help protect your VMs from disasters by using Azure Site Recovery. And if you click that little Setup Now button, you would see the similar sort of pane that shows up that will ask for your, you can select from a drop-down the subscription and resource group from Azure, link it to a workspace, and then you're able, when you click on one of your VMs, you'll see this new button to protect them. And when you click Protect, it starts seamlessly uploading that data to the cloud, and it does that every 5 minutes, so that in the event that something goes wrong, you have the latest copy of whatever compute workload you were running, and you can restart that in the cloud. And so let's skip over this video. And now, the last big hybrid integration that we did is with is the ability to set up a cloud witness. So when we think about witness types, and you look at us versus the competitors, you'll see that there's 3 ways to set up a witness. You can deploy a full server, which obviously just defeats the purpose in both scenarios, because you don't want the hardware, you want something more lightweight. For our competitors, you would set up this thing called a VM, called a witness appliance, which basically is a new VM that you're spinning up, so that requires compute, storage, and just takes up a lot more resources than you need. Our equivalent for that is using a file share witness, so that you just write a few kilobytes where you need it, and it provides that extra quorum vote for you. Now, a new thing that we added in Windows Server 2019 is introducing quorum without using any of these types. So we basically let you use a USB witness that you can plug in directly to your router or switch that provides this sort of capability. And this is really good for those lean two-node remote branch office scenarios. The reason we designed this feature is because we were working with Doctors Without Borders, and we saw that when they were going to these remote places where they may not have internet connectivity or they may not want to bring extra hardware, this is the perfect lean solution that they can just plug into their existing networking setup and get that extra volt to provide that level of resiliency. And so in those disconnected scenarios, we have this really lightweight USB witness. But let's say you are connected to the cloud and you want a leaner experience rather than running a VM appliance in the cloud that has the same sort of high storage and bandwidth requirements. We provide this thing called the Cloud Witness, which uses this technology called Azure Blob Storage, which basically is only writing a few kilobytes to the cloud to provide you that same level of lean resiliency so that you don't need to spin up a lot of resources and have high monthly charges for that. It only provisions the little bit of storage that you need in the cloud so that you can extend your on-premise footprint to the cloud for the exact services you need. And we've built a way for you to set that up through Windows Admin Center. Once you have a storage account in Azure, you just copy the ID of that storage account, and you go to Settings in the Windows Admin Center page. You'll see Witness, and you just copy and paste that information, and it automatically links it. And unfortunately, this demo won't work, but that's exactly what it would have shown. And so in this scenario, you've now enabled your remote branch office scenario to now have that extra vote and be more resilient for your small-scale setups. And so overall, with Azure Stack HCI, we've built a lot of these hybrid scenarios in the last year. And as a technology as a whole, whether you're the small-scale branch office or operating at the edge scenario, all the way to needing to have 16 nodes, perhaps using cluster sets to scale out your node and storage capabilities, we've built this software to cater to both segments. And so we see a lot of enterprises that we work with use in their central offices where they have data centers. They use this technology on their main data centers, and then in their remote and branch offices, they use it on a smaller scale deployment. And so if you want to learn more about this, you can go to Microsoft.com/HCI, and you can see all the lovely solutions that DataON and our other OEMs are providing. You can sort and optimize by we have different badges now for the different scenarios. So you can sort by branch office and edge, you can sort by high performance, and you can see the exact configurations that are available to you. And this is how you can get started with other solutions. This is a link to download Windows Admin Center so you can deploy and manage. And if you go to azure.com/hybrid, you can see how to connect using these different hybrid services. So that's everything from me. Thank you for having me on the call, and I'll stay on if you have any questions.
Thanks, Adi, for a thorough presentation. Next speaker is James from Intel.
Thanks, Howard. Hey, so I'll dive right in to follow up with what Adi had to say about the Azure Stack HCI, which is a pretty amazing product, especially in the light of a data center transformation. That transformation is happening where data is becoming the commodity and the important ingredient in being able to get value from that data is really critical within that environment. The key to be able to access that data, though, is to have a platform or flexibility of a platform that's going to meet the demands of the workloads. And the workloads are changing as people are appreciating the value of that data. No longer do you just have your standard IT workloads with SharePoints and Outlook and things like that, internal departmental web pages, but you're adding in artificial intelligence and you're adding in intensive computational machine learning algorithms and all sorts of analytics that you're running to monitor your customers and the opportunities. And really what that calls for is a system that's highly performant and highly flexible. It can be configured to potentially meet a large-scale workload's needs, or configured to be flexible to meet a large variety of workload needs. But it's really important as you build these configurations that you're paying attention to not only the availability features, which Adi was very clear on, data availability and monitoring and new enhancements to make it more operationally efficient to run Azure Stack HCI. But you also need to look into the hardware ingredients and how you put them together. And that's why Intel cares so much. The other thing you need to pay attention to is what are the needs of the organization. And again, the operational needs are critical, and that's really a big part of what's driving hyper-converged infrastructure and solutions like Azure Stack HCI out into the market in big force. These solutions that run very well, that are efficient, that are easy to set up, use, and configure, that can automate operations, eliminate silos. But you do also need to pay attention to sizing of both the storage capacity as well as the performance for the applications, and making sure that you can deliver to your corporation's needs and make sure that you're adding value to the company within the IT rather than being a roadblock or being an impediment. And so that's where we like to talk within Intel about the hardware ingredients, and specifically about what we see in the memory and storage hierarchy, because it's very common within hyper-converged infrastructure that some of the bottlenecks you see could be around either the system memory or the capacity of that memory, or the storage performance, or the storage cost. And so when we look at the world, of course I'm in the storage business within Intel, we look at this pyramid and the dynamic of the data in this data-centric world, and we see that basically between DRAM and 3D NAND SSDs, really there's an opportunity because there's a gap in terms of the capacity that you can generally put in a server efficiently, cost efficiently, from a DRAM perspective in the memory side. And then in the storage, there's a performance gap that can limit these high performance memory or storage intensive VMs, things like running analytics or transaction processing concurrently, running all sorts of new machine learning or AI. It puts a large demand and tax on the storage I/O as you're accessing these very large data sets. And then of course capacity. You want to store more and more data so that your business and your analytics can take advantage of broader data sets and can learn and become more accurate over time. So that poses these gaps in this traditional hierarchy. And that's why Intel's been focused on some new technologies that some of you may have heard of and others may not have, but specifically Intel Optane data center technology and Intel 3D NAND technology in terms of both NVMe SSDs and QLC SSDs. We've really been focused on trying to fill these gaps where the persistent memory fits in to enable larger memory capacities and fill the memory gap, and the Optane data center SSD helps improve the storage performance and provide both performance and endurance to this equation. And then 3D NAND brings cost-effective capacity to the equation. When you look at these technologies, there's a good opportunity to leverage those and understand them a little bit more. But I thought, rather than dive immediately into how they fit into Azure Stack HCI, I might talk about Optane technology itself and the data center SSD that utilizes Optane. What is exactly Optane? So if you're familiar with SSD technology in SATA and both NVMe, those are generally traditionally built using what's called NAND media. And NAND media is a storage device that's been around for probably about 20 years, but been in volume production in data centers for about the last 10 to 12 years. And we haven't really had an advancement. It's been growing and growing in capacity, but typically the performance per gigabyte generally starts to shrink. And what that causes is challenges with accessing the data in a timely manner as the data sets grow. And so we've invented Intel Optane technology, which is a brand new memory media that's used inside these SSDs. And it's not only that media, that's 3D crosspoint media, but we've also got a new controller and a set of firmware that we can build around this because of this new great technology. And ultimately what that delivers is very, very high endurance, very, very, very low latency, predictable quality of service, and even better throughput, especially in mixed workloads. You can see from the graph on the right of this chart that latency, and the reason we invented NVMe at Intel, was really aligned toward the future technology and this Optane technology that we were bringing to market. to try to reduce the latency in the stack from the controller interface. You see, as we moved to NVMe, we eliminated that orange color, and that shrunk the latency of the controller, but the media, as the blue color, took on the majority of the latency. And so with Optane technology, the media latency has shrunk now to almost imperceivable in the context of an SSD. So as you look at that, the important things when you put it into an Azure Stack environment are really two main ingredients as an SSD. The first of which is the endurance. So you can think of a storage cache at the beginning and the front end of a storage system. There's always writing hot data, and some of that data is written and then read and then rewritten and read before it actually settles and it becomes very hot. And if you want to use a very cost-effective back-end storage technology, like a standard endurance or even a QLC read-intensive NAND SSD, you really want to try to minimize the extra writing that you do to that particular media. And that's where Optane technology comes in, providing up to 20 times more endurance than our highest endurance NAND SSD, and it's on the order of 60 times more endurant than a standard SSD, and as much as 100 times more endurant than a QLC SSD. So it makes for a really good technology to absorb all of that hot data and make sure that it settles, which Azure Stack HCI is very well aligned to with a caching layer. When you look at that from a cost perspective, if you're going to assume that you're going to have some very large ingest of data in the neighborhood of, say, 60 terabytes of storage, and you wanted to manage that 60 terabytes of data with Optane SSDs, you can do that today with 3 of our 375 gig devices, manage 60 terabytes of ingested data a day, or dynamic data. And you can do that at a very low cost. And if you were going to do that with a high endurance NAND SSD, you'd need 10 of those SSDs. And so, and not only that, but they come in larger capacities. So you're adding the cost up fairly rapidly. So the opportunity, if you're going to have lots of dynamic changing data, to protect that data with a layer of very high endurance cache in front of it, to allow the more settled and less dynamic data to be destaged into the warmer tier of storage. That's where Optane brings a huge value in these solutions. The other thing we see with Optane technology, it is quite different than NAND. When you look at NAND media, NAND, it has to erase very large page areas. You see that shown in blue. We arrange the data in pages rather, and we erase the page. We align the pages into blocks, and you have to erase an entire block. So you have to erase a very large amount of data to clear the data out, and NAND has to be erased before it's written. So you have to have some pre-erased space. What that causes is, over time, as you continue to change some data, that means that these older erase blocks are going to have some valid data and some invalid data. They start to look a bit like Swiss cheese. And then you have to recover that. And in order to recover that, you have to move the valid data that's still in an erase block to some new area, and that takes time away from the customer or your performance while we do this internal cleanup and internal garbage collection in NAND. And then we erase the block, and then we start writing again. It causes delays, it causes stalls, it reduces the bandwidth that you get from the host interface or from the user perspective. The Optane technology is a write-in-place media. You don't have to erase before you write. It's also arranged in a way that every single bit can be addressed inside the SSD by the SSD controller. So what that means is you don't have any garbage collection. You simply write or read data. You can write or read in place. You can make aware leveling a secondary opportunity. It's not something that's right in the forefront because you're not having to garbage collect. And that provides far more consistent, predictable, lower latency to the technology. Now, when you put that in the context of a system and how you use that, you can think of a cache SSD. And this particular graph describes that. What I've got is two axes. On the left is a write pressure. I'm inducing a heavy write workload into a cache, which is very consistent with ingesting data, running a clone, running some sort of an ETL event. And consistently, I'm doing that on, say, several VMs. And on other VMs, I'm trying to read data, transactional data, respond back to my user with a response, with an answer, with an order record received. And so that right-hand axis is the read response time from the device itself. So what I've got is our NAND SSD on the top, the silver one with the gray chart. And the read response, the lower the better, and the more consistent the better. And you can see with the NAND SSD, as you increase the amount of write pressure to the device, the reads become slower, it's higher on the graph, and more inconsistent. They become very variable. What that means as a user, if you're trying to use a NAND SSD as a cache device, your responsiveness is not predictable and it slows down depending on how much work you've got going on because of that garbage collection. But the cool thing about Optane is that black SSD on the right with that very tiny blue line at the bottom of the graph that actually looks like the horizontal axis. That's the read performance of the Optane SSD under that same write pressure. And so that's important in reading and responding back to the customer. It's also important in reading and destaging the data back to the back-end tier. So you can think of it, if you can be efficient at moving that data out of the cache layer and move it either to the customer or back to the back-end tier, and you don't have these stalls, then that ultimately means you have great performance, but it also means you need less capacity in that caching layer because you don't have to worry about all these stalls, you don't have to worry about things getting backed up, you don't have to have a large capacity buffer to be able to absorb extra work. You can simply disposition it quickly back to the customer, let it become stale and erase it, or destage it back to the back-end tier. So that makes OptaneTechnology far more efficient and performant. So now how do you integrate that into Azure Stack? I've already kind of forecasted a little bit. In Azure Stack HCI, as a cache device, if you simply take a standard flat tier of SATA SSD as an example, which is a very common lower cost configuration for Azure Stack HCI, and you add a caching tier of Optane SSDs, you'll find that SATA SSDs can actually limit the performance of the system and limit the number of VMs you can run per physical core. And we find that ultimately that allows you to potentially build a cluster a little bit more efficiently. And in this case, we just simply add the Optane SSDs as a cache device into a cluster. And because of the availability of that cluster, you can move from a 4-node to a 3-node. And at the same time when you move to a 3-node, including decreasing one node, you're still getting 52% more IOPS and 26% less latency. What that really allows you to do is build a more balanced platform and unleash the CPU. It allows you to be able to use more of the CPU. You can potentially run 4 VMs or 4 vCPUs for every core in this case, and get a whole lot more value out of that CPU, out of that cluster. By spending and adding a small amount per node, you get a tremendous more performance. You can run far more VMs and you need less nodes. Now, when we look at the Optane technology, when you look at it in the DIMM form factor, which is the Optane Data Center Persistent Memory that I mentioned on the first page and I haven't talked much about yet, that gives the opportunity then to expand the memory set very cost effectively. And so in this case, it gives the performance which is very close to memory and the cost which is much closer to DRAM. So when you balance this platform by putting in the Optane SSDs as cache, you've actually created a new imbalance. You're now able to run more virtual CPUs for every physical core in the CPU. But now you might have a memory constraint, and that's the new constraint. And it's not really a memory performance constraint as much as it is a memory capacity constraint. You need more memory to be able to service more VMs in the platform. So the most cost-effective way to go forward then is to add the data center persistent memory to the technology and use that as additional memory. And so when we did that in this case, we were then simply taking a very similar system, and then after we've scaled up the storage performance, we then scale up the memory capacity, and that allows more room for more VMs of a certain size. And in this case, you can see potentially 36% more VMs per node. And again, that goes right to the bottom line when you put that in there. So not only do you get greater storage performance from the Optane SSDs, you get more memory capacity from the Optane Data Center Persistent Memory, and you can build a more optimized, more balanced platform that allows you to bring any workloads you want and take full advantage of the CPU and the cores that you've brought to the table. So with that said, we've been working together on this for quite some time with the DataON folks as well as with Microsoft, and we're really excited when we brought the technology to StorageReview and they have taken a look at it. So they can simply take advantage of this technology and test it and say, hey, how does this stuff perform? So I'll hand it off to Brian now, where Brian can talk a little bit about the testing that they did and why they decided to give our joint technology an award.
Thanks, James. I appreciate the lead in and you did a good job telling us about the latest technologies. You and Howard sort of stole our thunder on this editor's choice situation, because when we started, we were a little bit, not apprehensive, but just unsure what to expect from Azure Stack HCI and the DataON solution. In all transparency, we started the review without ever doing a project for DataON before, and with having sort of limited experience with the Microsoft solutions in the past. And we had worked with them on an initial iteration of their hybrid cloud solution with Azure PAC, but we hadn't done anything with the hyper-converged solution. And anytime we go into these things not knowing exactly what to expect, we normally expect the worst. But as you've already heard from the discussion on the Editor's Choice Awards, we were tremendously surprised with the outcome of our review. So just to level set on what it is that we were looking at for this particular review, it's fair to note that while James highlighted a lot of the new technology Intel has to offer that they launched this year in conjunction with the second-gen scalable Xeon processors, our review cluster we started on was out a little bit before then, but still is a great configuration in terms of appropriate CPU for the workloads, plenty of RAM in the systems, and the combination of both Intel Optane SSDs and Intel standard capacity-centric SSDs in the P4510s, all of them still NVMe, which is an important consideration because the platforms that Intel and DataON are shipping here are totally NVMe ready, at least in these SKUs, and that's not something that everyone can offer for Azure Stack HCI. Our stack also included Mellanox switching in their domain controller. It was all delivered and highly documented in terms of where everything goes and what connects to what port, which is actually somewhat unusual. We don't normally get that level of complete documentation, so that was another pleasant surprise in working with the DataON team. Kevin really likes photos, so he's got a nice glamour shot of both the capacity and the NVMe drive there as well, so it's always fun to see the gear that's under load. So in terms of our benchmarking, we ran a number of workloads and synthetic and application against the cluster, and just wanted to highlight a couple of them here. And one thing to note is that we initially ran the configuration in a two-way mirror configuration, and we did so in order to achieve maximum performance. And the numbers were great, as you've maybe seen before if you read the review, or as you'll see here. And we took the numbers back to DataON and Microsoft, and the guys said, wow, yeah, this looks great. These are really nice numbers. But what we'd really like you to do is run three-way mirror. And we were both, Kevin, who runs our lab, and I were a little shocked about that because most vendors we work with just want to post the hero numbers and show the best case scenario. And Microsoft, to their credit, and Howard from DataON said, yeah, let's do it. Let's show what the flexibility is in the platform. And so when we look at some of these basic workloads, like this one's a 4K random read, we're seeing over 2 million IOPS with great latency, both in two- and three-way mirror. Now, there's a little bit of a hit on the three-way mirror in terms of write performance, but it's relatively modest, and depending on what your workloads are, you can decide the trade-off there between resiliency and ultimate read and write performance. Going forward to large block sequential, we see a similar thing where we get nearly 40 gigabytes per second in two-way and 45, 46 in three-way. Again, really great numbers, and the second bullet there highlights one of the reasons why we were so excited about this solution, is that the numbers are simply fantastic. And we've looked at a lot of products in HCI, we've looked at a lot of solutions that are software-defined, and the level of completeness and being ready to roll out of the box and still driving these types of numbers with the Intel-backed DataON solution was really quite astounding, and something that we just haven't seen. You know, a lot of the SDS solutions out there today require a lot of manipulation, configuration, and some of those are being done in the channel or by VARs or whatnot before they get to a customer. But what we got out of the box ready to roll here was fantastic. Looking over to SQL Server, again, we're looking at almost 2 million IOPS for both 2- and 3-way configurations, and fantastic latencies across the board. The other big thing outside of performance is management, and I'm sure you've heard about WAC quite a bit before. The management interface through Windows Admin Center is really strong. Highlights all the important information without having to drill into all the nodes. And this actually, we saw the 2-node views earlier in the Microsoft part of this presentation, but as you scale nodes, the management becomes much more important. It's used to manage and monitor your Azure, manage site recovery, which incidentally, there was a little conversation on site recovery earlier. We've gone on since the review and done a dedicated piece on Azure site recovery, so definitely check out the site, or Howard will post a link later to highlight that. But that's another really great solution, especially for the edge and remote use cases, to be able to have this simple set of hardware to manage on site, and then also knowing that you've got some resiliency available to you in the cloud. One of the best uses of the cloud at the edge, which is a nice integration here. The other piece is DataON has an additional software package to help manage and monitor the solution called Must, which is just another great asset and another big differentiator between what's available in terms of management and monitoring when you compare the DataON solution to other avenues to get on Azure Stack HCI. So we don't want to belabor it too much, but just a couple of the key performance highlights. As noted, the 2-way, 3-way mirror flexibility is pretty critical here to let you tune the solution for your needs or for your customers' needs. We saw great throughput. We saw just performance, like I noted, that was well beyond our expectations. One of the big things, though, too, that's important here is the back-end fabric. So let's not minimize that. One of the reasons why this was so successful from a performance standpoint is that the nodes were properly spec'd on networking. If you had tried to do this with 10 gig or anything really less than what we ran, you would have saturated the interface connections and really capped what the Optane drives were capable of performing at. So it's an important thing as you look at these builds to make sure that networking, both in the nodes and the switches, are capable of achieving the performance goals. And because of the networking, because of the quality components and the optimizations Microsoft has made on the software stack, we saw fantastic latency throughout the entire time. And it's not just performance. That tends to be our focus, but we also like a lot of the other things that we found in this solution. First of all, the server platforms that are Intel-based are fantastic, really well designed for this use case. I talked before about having 24 bays of NVMe across the front. That is done by some vendors, not everyone, but it's not always done well, which means that there could be compromises in the ability of the PCIe lanes to manage all of the storage and performance, but we didn't find that to be an issue here. So out of the box, you're talking about a really solid hardware foundation. Deployment from box to rack, we did that in-house as part of this review. The documentation that came with these systems was fantastic, to the point where wires were color-coded and numbered. This one goes here, there. And we had worked with DataON on the topology before it even shipped to make sure that we were ready to go when it gets here. The other thing, too, from an Azure Stack HCI perspective is that from a hardware and software maturity, in addition to the special Must application that DataON adds, the overall solution is really quite mature. The plugins for Azure to do site recovery is fantastic, and some of the new capabilities around monitoring and other storage enhancements that Microsoft's offering are really quite exciting. So overall, we were thrilled with this. We're happy to answer any technical questions or other questions you may have. and my information, and Kevin's, who runs the test labs on the screen. We're always welcome to receive your feedback and participate in the conversation. So that's our bit. We're excited to do it, and I don't want to ruin your plans, Howard, but I know we've talked about doing another cluster review next year, so you better be ready to go for us.
Hey, thanks, Brian, and this was really good. I think I want to take the next 10 minutes to some Q&A because there's a lot of great information that was shared through today's presentation. I think one thing that really resonated with me and that comes back continuously is that the discussion really revolved not around hardware, but really revolved around the solution and workload, right? Whether or not is the workload optimized design that Microsoft is looking at in their design, whether or not it's for edge, is for SQL, is for converged storage, or whether or not is the Optane SSD latency optimized for a specific workload that require higher throughput and requires the fact that for databases you need no latency. And the fact that Brian, when he did the test, these 4K and throughput tests are not random. These are synthetic workloads that's happening today with our customer base, right? Today, it's very difficult to take a customer database and say, I'm going to run every single one of them. But our goal is to continue to mimic or represent a type of workload that is a representative of what our customers are using today, right? Whether or not it's a SQL workload, whether or not it's a file backup workload. These are very critical pieces because at the end of the day, the customer is buying a complete solution. That is Microsoft Azure Stack HCI. And these solutions are going to run your day-to-day application and day-to-day workloads. So Adi, a question to you is, what prompted Microsoft to shift this to talk about workload and really address the fact that the solution, the Azure Stack HCI, is really workload-centric?
Yeah, I think we just talked to a lot of customers, and we saw that as, like we talked about with the Azure IoT Edge VM module, like we saw that as people were installing this new HCI hardware, they wanted their systems to be more resilient to these compute workloads and changing workloads as they were innovating separately, and they wanted those innovations to apply and bring them down on premises. And so just based on that customer feedback, it's changed a lot of the product strategy and roadmap internally. And so I think that's what really prompted it.
Got it. And James, and I know that, Intel has so much technology out there. Clearly, Optane is one of the leading technology as a storage media. From your experience and talking to customer, your OptaneTechnology, what are the key workloads you guys address in terms of customer applications?
Surprisingly, it happens to trend toward more of the typical and average workloads. From a density perspective, people are looking to try to consolidate infrastructure, move it to more manageable platforms like a hyper-converged infrastructure. And when you take OptaneTechnology as a caching layer in hyper-converged as an example, that's a real common place where people actually can take and quickly appreciate that value without doing anything more than just dropping it in. We've got delusions of grandeur with respect to the world changing about how data architecture works in computing, and we're driving for it. And don't get me wrong, they're not complete delusions, but it's going to take a while. But right now you can drop Optane into the solution like Azure Stack HCI and get the value today, and it's very measurable, and it's not just fluff.
And we agree, and there's many data points that of hundreds and hundred deployment we have done with Azure Stack HCI. It really has shown that Optane could really deliver that type of capability and optimization we like. And Brian, last question to you before we wrap up. As you continue to look at solutions, you see the world holistically, whether or not storage, HCI. How do you see the trend of HCI and leveraging the software-defined that Microsoft's presenting, and how these really address the different challenges that customers you're seeing have?
Well, I mean, there's a couple things in there. One thing, and I would echo what James is saying around HCI, and when you put high-performance components in there, it's not necessarily for a workload to be able to benefit from Optane or persistent memory or any of these technologies. What we're seeing, and I'm sure you are too, is that a lot of customers, when they move into HCI, they don't necessarily know what to expect, but as they put the workloads on and see the performance and the capabilities, we're seeing these clusters that started out small being given lots of workloads that were maybe unexpected. So, it used to be common for HCI to be deployed in silos like VDI, but now a lot of times we're seeing transactional database in addition to VDI, in addition to shares and other things that are important to an organization. So that's one of the big things that we're seeing, is to not necessarily think about a monolithic workload, but to think about it as something that can handle what is effectively a bunch of mixed workloads all jumbled up together and still handle that well. So I think that we're going to continue to see this upswing in this methodology. I think the exciting thing for DataON and Microsoft is probably that not enough people know about the solution and know about the capabilities of Azure Stack HCI. So as more and more people get exposed to this via this webinar, via the content and the reviews we produce, and the continued excitement that Microsoft's pushing around these solutions, there's a lot of upside to be gained.
Thank you so much, and thanks, Adi, James, and Brian, for taking time. I know the holidays approaching. All of us are looking forward to a good, relaxing holiday season. We look forward to partner with all of us together starting 2020 and showcase to our customer more exciting technology and evaluation to show what type of other solution we could deliver to run their application. Thank you, everybody, for attending. Appreciate your time, and wish everybody a great holiday.
Thank you. Same to you.
Thank you. Bye-bye.